Hello everyone, welcome to today's math adventure on DigiTutorials. Today, we're diving into the fascinating world of relations and functions in mathematics. These are fundamental concepts that underpin much of what we do in math and science. A relation at its core is any set of ordered pairs. Think of it as a way to connect two pieces of information, establishing a link or correspondence between them. A classic example is students and their test scores, where each student is related to their performance on a test. Now, functions are a special, more refined type of relation. They adhere to a key rule. Each input has exactly one output. This is what sets them apart. This one-to-one correspondence makes functions predictable and incredibly powerful tools. They are essential for modeling real-world situations, allowing us to understand and predict outcomes. Consider the path of rockets, or the projection of business profits. Understanding functions is absolutely essential, especially as you progress to higher-level math courses like algebra and calculus. They form the bedrock upon which these subjects are built. Whenever you see a graph illustrating changing temperatures over time, or use a formula to calculate the area of a shape, you're actively working with the principles of relations and functions. In this video, we'll break down exactly what relations are, exploring their properties and characteristics. We'll also delve into what makes a function so special and unique, highlighting the importance of that one-to-one input-output relationship. You'll learn how to recognize functions, how to use them effectively, and how to apply them to solve problems. We'll also introduce you to function notation, which is the concise and precise language that mathematicians use to describe these powerful ideas. By the end of this lesson, you'll clearly see how these concepts help us make sense of the world around us, providing a framework for understanding complex systems. So, let's get started and unlock the power of relations and functions. Data in math often forms patterns, revealing connections that might not be immediately obvious. These patterns are the key to understanding the relationships between different sets of numbers and variables. And these patterns reveal the type of relationship between numbers. Recognizing these relationships allows us to make predictions and draw conclusions. The most basic is a linear relationship, a fundamental concept in mathematics. Like earning $15 for every hour you work, a direct and proportional increase, which graphs as a straight line, indicating a constant rate of change. Quadratic relationships, which introduce a squared term into the equation, like a ball's path through the air, influenced by gravity and initial velocity, form a U-shaped parabola, showcasing the effect of the squared term. Square root relationships, where one variable is the square root of another. Start steep and flatten out, demonstrating diminishing returns as the input increases, showing growth that slows over time, a common pattern in natural phenomena. Reciprocal relationships, where one variable is inversely proportional to another. Create two curves that approach the axes but never touch, illustrating the concept of asymptotes, like speed and time for a fixed distance, where increasing speed decreases the time required. Cubic relationships, involving a variable raised to the power of 3, look like stretched S-shapes, indicating more complex interactions between variables, showing rapid changes and plateaus, reflecting the influence of the cubic term. Recognizing these patterns and understanding their underlying equations helps us guess the underlying rule connecting two quantities. Is it a straight line? That's linear, indicating a constant rate of change. A U-shape? That's quadratic, suggesting a squared relationship between variables. Spotting these shapes and understanding their mathematical properties is the first step to building mathematical models. With these models, we can begin to predict and analyze using mathematical equations to forecast future outcomes and understand real-world data, gaining insights into complex systems. That's the power of recognizing mathematical relationships. It allows us to make sense of the world around us. To understand relations and functions, we need to know about variables. The independent variable is the input. You control it. The dependent variable is the output. It depends on the input. For example, if you buy concert tickets at $50 each, the number of tickets is independent, and the total cost is dependent. In plant growth, water amount is independent, plant height is dependent. In baking, oven temperature is independent, baking time is dependent. Identifying these variables helps us set up equations and functions. It's the first step in modeling any real-world situation mathematically. Always ask, what do I control and what changes as a result? Now let's talk about function notation. It's a fundamental concept in mathematics that provides a concise and efficient way to represent and work with functions. It's essentially the language of functions, a symbolic way to express the relationship between inputs and their corresponding outputs. Instead of writing y equals sine 2x plus 3, which you might be familiar with, we write fx equals sine 2x plus 3. This notation offers a more descriptive and powerful way to represent the same relationship. Read it as f of x. It's important to pronounce it correctly to avoid confusion. Here, f is the function's name. It identifies the specific function we're working with. And x is the input, the value we're feeding into the function. The entire expression fx tells us the output, the result we get, for any given input x. For example, if we want to know the output when the input is 4, we need to find f4. To do this, we substitute 4 for x in the expression. So f4 equals sine 2x4 plus 3, which simplifies to 8 plus 3, and finally equals 11. This means that an input of 4 gives an output of 11. We can represent this relationship as the ordered pair, 4, 11. Remember, you can use any letter for the function name. For instance, we could define a function as gt equals sine t2, 1. If we want to find g or 5, we substitute t with 5, so g and 5 equals sine 52, 1 equals sine 25, 1 equals sine 24. Function notation keeps things clear, organized, and easy to understand. It's a powerful shorthand, a compact way to express complex relationships. It's essential for describing, analyzing, and evaluating functions efficiently. You'll use it everywhere in math, from basic algebra to advanced calculus and beyond. What makes a function special? Every input has exactly one output. In a relation, an input might have multiple outputs, but not in a function. Think of a vending machine. One button, one snack. If you get random items, it's not a function. Here's how to check. Use the vertical line test on a graph. If any vertical line crosses the graph more than once, it's not a function. For example, a circle fails the test. A vertical line hits it twice. A parabola that opens up or down passes, the line only hits once. The vertical line test is a quick way to spot functions visually. If every input matches just one output, you've got a function. That's the key difference between relations and functions. Hope you find this video useful. Please share with your peers. That's it for the summer. Enjoy your break and see you back in the next school year.